Let's take a look at another application of solving linear systems by substitution. Now, if you saw the previous section, the previous video on the application, this is actually just an extension of that actual situation. So let's go ahead and take a look. We have the situation of Paul receives his monthly statement from his investment site, TradeHouse. I guess that's actually the site that he chose over eShare. So he discovers that he paid $35 in total fees. TradeHouse charges $5 per trade and $1 per option, which is a different kind of trade, as well as a flat rate of $10 per month. If Paul made 9 transactions, how many trades and how many options did he trade? Okay, so let's go ahead and label a few variables. So let's let X equal the number of trades, and we're going to let Y equal the number of options. Now we're labeling these variables as such because our total cost is already known and our total number of transactions is already known, plus the cost of each type of transaction is known. So what we need to know is that our cost is a function of both different types of trades. So we're going to let X and Y equal the number of trades and options because we don't know, and we want to find out how many trades and how many options that he made. So we know how many total trades and what the cost of those are and the total cost. So we just need to know the number of the different types of trades. All right, so we have our variables labeled. Let's go ahead and write a couple of equations. So we have, what do we know? We have number of transactions is 9, so we know that our first equation can be number of transactions, and we're given that information, or we're given the total of it. 9 is going to be the total of the number of trades and number of options. This is all the trading that he's doing. So it's going to be X plus Y is equal to 9. The number of trades plus the number of options is the total number of transactions. All right, so far so good, pretty simple. Now let's write another equation. We know the equation for the total fees. Total fees. This is the total amount that TradeHouse is charging him for the month. We know that the number of trades times $5 plus the number of options times $1 plus the flat rate of $10 per month is going to give us a total of $35 in total fees. So we can write the equation as 5 times X plus 1 times Y, or just Y, plus 10, that's for the flat rate, the monthly fee, and that's going to equal $35. So we have 2 different equations here, and we can use the substitution method to actually solve these equations. So let's see how we're going to do that. Well, this one's pretty simple. When we're using substitution, we need to solve one of the equations for one variable in terms of the other, and this one we can simply subtract X from both sides and get our equation solved for Y in terms of X. So let's go ahead and do that. So we have X plus Y equals 9. So let's go ahead and subtract X from both sides. Those 2 terms will cancel. So we have 9 equals minus X plus 9. And what we can do is we can substitute that into the second equation. And we can solve for X and get a value for X. And that'll make things much simpler. So we have the following equation. We have 5x, or excuse me, we don't need the parentheses. That's already in there. Let's try this again. We have 5x plus y. Now y is just minus x plus 9. So let's go ahead and write that in parentheses since we're substituting in. Even though we're just adding, we don't really need the parentheses. And then we have plus 10 equals 35. All right, so now we have one equation in terms of one variable, and we can actually solve this to get the value of that variable. So let's go ahead and do that. So we have 5x minus x plus 9 plus 10 equals 35. Now we can combine some like terms. 5x minus 1x is 4x. 9 plus 10 is 19. We still have 35 on the other side. Let's go ahead and subtract both sides by 19. These 2 terms will cancel. So we have 4x equals 35 minus 19 is 16. And we can isolate x by dividing both sides by 4. So we have X, the number of trades made in that month is 16 over 4, which is 4. So we have the value of X. Now we want to know how many trades, what the value of Y is, how many options he's made. And we have just a simple equation right here that we can plug into either one, but let's just plug into this one, just make things simple. So we have X plus Y, so we have 4 plus Y equals 9. We can subtract 4 from both sides. That'll render the equation Y equals 9 minus 4, which is 5. And we have our two answers. So if Paul made 9 transactions, how many trades and how many options did he make? And we can go ahead and formally write our answer. We can say Paul made, and this is the interpretation of the answer. This is actually a really important part as well. Transferring information from a word problem to the particular equations is by far the most tedious and I would say the most important part. Actually interpreting the answer would be the second most important part. All right, so Paul made, X is the number of trades, so he made 4 trades. And Y is the number of options, so he also made 5 options. Options is a really good investment vehicle. Maybe I'll do a series on finance and investments. But this is our official answer. So we're answering the question, how many trades and how many options did he make? He made 4 trades and 5 options. So this is a really good application to see the usefulness of solving linear systems of equations by substitution. And it actually makes things fairly simple. We could have graphed this like in the last one, but this one isn't quite as continuous as the other one. It's more discrete. We made 4 and 5 trades. We weren't looking for if a number of trades was less than 7 or greater than 7 like we did in the previous application. So look over this a few times. Make sure you understand how we got from the word problem. We extracted the keywords and the information, and that's how we constructed some equations and labeled our variables. Everything else we should have plenty of practice on. We know how to do by solving linear systems by substitution. In the next section, we'll be solving linear systems by what's called elimination, or just basically using addition and subtraction, when we'll be adding or subtracting one equation to the another one. So I'll see you in the next video.